This is the introduction to chapter 5.1. We'll look at some definitions and some ideas of probability. So you have your 5.1 note sheets out. And so you can also, again, follow along with the PowerPoints online or with the textbook. So the first thing we want to introduce to you is the term probability. What is that? Probability is a measure. It's a way of us describing the likelihood of some event happening and specific likelihood of a random phenomenon or chance behavior occurring. Probability describes the long-term proportion with which a certain outcome will occur in situations with short-term uncertainty. Probability is all around us. You guys make decisions in your life every day based on some likelihood that you know what the outcome's going to be. Some people think that life is just a big experiment and that we run these experiments and we should be able to predict our outcomes. Probability is this measure, and we describe probability using different terms, which is we're going to look at. The first thing I want to introduce you to is this idea of using an applet to kind of simulate something for you here. I want to flip a coin. Let's see if we can get to there. We're going to flip a coin. It's set up in StatCrunch. You don't have to do this. I'm going to show it to you. So let's go coin flipping. Probability of getting the heads is 50%. So we'll do that and we'll flip one coin. Let's take a look at what that's going to look like. It's going to keep track for us. So for example, I run once. It comes tails. And so we have one tails and no heads. Let's run that one more time. Flip the coin, tails comes up. Now I'm going to have two tails and no heads. Let's speed this up a little bit. I flip it 5 times. We can see a result. We now run a total 7 times. 2 have been heads and 5 have been tails. And so we know that it's supposed to be 50-50. We've flipped. Let's flip 5 more times to get us to 12. Theoretically, it should be 6 and 6. Right now, we have 7 tails and 5 heads. So the idea, though, the more we flip the coins, the more that it should balance out. But in short term, notice, even though we flip 17, we have 9 tails and 8 heads. And so I'm going to run it 1,000 times. You can see after 1,000 times, our proportion's around 50%. We have 508 tails and 509 heads. So it's almost balanced out, but we had to flip 1,000 times to get there. And so you can see that even though the probability is half, it doesn't always mean it's always going to be balanced out. It's an experiment, and if different people did it, you'd get different results. And so some terminology we want to get into. So some terminology we want to get into is this idea of, there's an important concept in statistics. It's called the law of large numbers. And that's the idea, again, is the number of repetitions of a probability experiment increase. Like I was going up to 1,000 by flipping a coin. The proportion with which a certain outcome observed gets closer to the probability of the outcome. So it's supposed to be 50-50, and when we flip the coin 1,000 times, we almost got there. And that's the idea of the law of large numbers. Some more definitions that we want. In probability, we use certain language. And so in probability, we consider the idea of an experiment, right? It's a process that can be repeated in which the results are uncertain. So that's what we call an experiment. You do something and we're not exactly sure what's going to happen. That's an experiment. We might have a hypothesis, but we consider that an experiment. And there's another term called sample space. And we use the capital letter S to represent that. And what is that? The sample space of a probability experiment is the collection of all possible outcomes. So think of some experiment, flip a coin. What are the possible outcomes? Heads or tails? Roll a dice. Possible outcomes: 1, 2, 3, 4, 5, 6. And so you want to make sure you're using the right language. Another word we use is an event. An event is any collection of outcomes from a probability experiment. An event may consist of one outcome or more than one outcome. We will denote events with one outcome, sometimes called a simple event. A simple event. In general, events are denoted using capital letters such as E. And so just to do the first example to end this video, let's go to look at sample space in events. The probability experiment consists of rolling a 6-sided fair die, which is just one dice. A fair die is one in which each possible outcome is equally likely. For example, rolling a 2 is just as likely as rolling a 5. Identify the outcomes of the probability experiment. So some of the outcomes, if you rolled, the outcomes would be a 1, 2, 3, 4, 5, and 6. What would the sample space be? Again, sample space is the collection of all possible outcomes. We abbreviate with a capital letter S, and then we use kind of this notation just to communicate that we're talking about a sample space, that this is a set of outcomes. And then define the event E equals to roll an even number. And so in a case like that, rolling an even number, the event would be equal to 2, 4, and 6. So this is the formal language we use to talk about probability and the ideas around us. We use probability and statistics because we're always trying to make decisions using statistics, and we need the idea of probability to support us with that.